Hello everybody, especially you, Liam224. I'm pretty sure you said in the live stream, sorry about the quality by the way. It was fun chat though, fun live stream. You said that this integral which I'm about to do stumped your maths teacher. Don't worry, sleep is a powerful tool. When I woke up in the morning, I had the solution. And here is how I did the integral of 1 over 1 plus x squared dx. Now the first thing you have to do, which I was kicking myself for not seeing in the live stream, is to notice that this is a sum of two cubes. This equals the integral of 1 over, and I'm going to write this as 2 squared cubed. Now what's the sum of two cubes formula? Well, a cubed plus b cubed equals a plus b, 1 plus x squared, times a squared, or x squared squared, also x to the power of 4, minus ab, or minus 1 times that, x squared, plus b squared, which is just 1 squared, which is 1, dx, okay? Now, there's the second thing here, which took me a while to find out, by a while I mean a long time, is that this equals the integral of x squared plus 1 minus x squared over 1 plus x squared, 1 plus x squared, times x to the power of 4 minus x squared plus 1 dx. And this equals the integral of, well, these two will cancel, so we're going to split it up, okay? These two will cancel, we're left with 1 over x to the power of 4 minus x squared plus 1 dx, we're going to close that, minus the integral of x squared over, remember that this denominator is nothing but x to the power of 6 plus 1 dx. Okay? And now we're making some good progress, because this can be easily done with u sub. If you look at this as u cubed squared, let u equal to x cubed, not u cubed, x cubed squared. If you let u equal to x cubed, you get inverse tangent, and with a constant multiple, this will work out nicely. It's this bad boy here, which is giving us the problems. Okay? So we're just going to focus on the integral of 1 over x to the power of 4 minus x squared plus 1 dx. Okay? And the trick here is that this again equals the integral of x squared minus 1 x squared minus 1 plus x squared over this whole thing, x to the power of 4 minus x squared plus 1. The problem is, minus, this should be a plus. The problem was, when I split it up, this factor here, this x squared over this, that just didn't work out nicely for me. However, I noticed that if I just put a minus 1 on the end, everything would be perfect. So what I did was, this dx, but now x squared minus x squared is 0. 1 minus minus 1 becomes 2. Promise, trust me. Do not put a minus 1, okay? That just won't, you'll go crazy. Instead, you have to put a 1/2 at the front. And that was the key insight which I was missing for ages. you have to put a half. I was about to give up on this idea, but then, you know, constant multiples, so nice. Okay? Anyway, so now this is good, and you'll see why. This is equal to the 1/2, and then I'll put big brackets here, times the integral of x squared plus 1 over this. We'll multiply the top and bottom by 1 over x squared. So we get 1 plus 1 over x squared over x to the power 4 minus 1 plus 1 over x squared. Not x to the power 4, x squared. Dx minus the integral of, same thing here, 1 minus 1 over x squared over x squared minus 1 plus 1 over x squared dx. And now I was reminded of the integral of the square root of tangent x, which was very similar to this. And the trick was there to factor the bottom. Okay, it doesn't factor very nicely. No problem. What we can just do is add on a constant, and then it all turns out nicely because of a certain formula. So why don't we try the same thing here? Because then when we let u equal to that, we get the inverse tangent, and then it's all so nice, okay? So this equals 1/2 times the integral of 1 plus 1 over x squared on the top remains the same. But now, we have x minus 1 over x all squared. The reason we're doing this is when we differentiate this, we get the numerator, okay? But be careful, when we do this, we're left with a minus 2 when there should only be a minus 1. So all we have to do is add 1, okay? And then we're left with this. Minus the integral of 1 minus 1 over x squared. Don't do exactly the same thing, because remember the derivative of this is that. So we want the derivative of this, for this integral, to be that. So instead of putting a minus, put a plus, and then add like whatever you need to add. X plus 1 over x all squared. That leaves us with the 2 extra, so we have to subtract 3 dx. And now, letting t equal to that, for example, this equals 1/2 times the integral of dt over t squared plus 1 minus the integral of ds over s squared minus 3. Okay? Okay, so this one's a lot easier. This one is exactly the inverse tangent of t, 1/2. But what's t? It's just this. So we get inverse tangent of x minus 1 over x, and then minus, there's actually a formula for this, which I always forget, so I always have to spend an extra 5 minutes just deriving it again. The integral of ds over s squared minus a squared equals the integral of okay, so this is the same thing as saying the integral of ds over negative a squared plus s squared, right? Multiplying by negative multiplying the top and bottom by 1 over a squared, negative 1 over a squared. Well, we can bring that to the front and then divide this whole thing by 1 over a squared. Multiply by that, okay. So this equals negative 1 over a squared integral of ds over negative. We already brought the negative out to the front, so we get 1. The negative and the positive becomes a negative over minus s over a all squared. Okay? do the u sub in your head. This equals negative 1 over a, integral of du over 1 minus u squared, which equals precisely negative 1 over a, inverse hyperbolic tangent of u, which was s over a. Okay? Don't forget the negative. So here, if we just look at the 3, the square root of 3 squared, then we can use our formula. So minus minus actually becomes a plus. 1 over a, 1 over square root of 3, inverse hyperbolic tangent of s over a, which is s is x plus 1 over x over a, which is the square root of 3. And then we'll just finish off this integral nice and quickly by looking at this as x squared cubed. Oh, wrong way round. By looking at this as x cubed squared. Do the u sub in your head. Let u equal to this. Du will be 1/3. Okay, you know what, don't do the u sub in your head. Let u equal to x cubed. That means that du equals 3x squared, or that x squared equals 1/3 du. We can bring this 1/3 to the outside, so we're left with 1/3 du over u squared plus 1, which is precisely 1/3 in normal inverse tangent of u, which was x cubed. So we're left with minus 1 over 3 inverse tangent of x cubed. Put down your plus c, box your answer, do whatever you want to make it fancy. And that one was for you, Liam 224. As soon as I got home from school, this one was for you. Goodbye.